So the problem that we're trying to solve primarily is the problem of how do people deploy and manage large application infrastructure. And when you think of large application infrastructure, this can be like websites, this can be APIs that power mobile applications, this can be backend services that IT teams run, and that sort of thing. Now, the style of how we think about managing these sorts of compute services is what we like to call GIFI, which is Google's infrastructure for everyone else. And what we're trying to do is bring kind of the secret sauce that companies like Google and Twitter and Facebook have used internally in order to manage their compute infrastructure, all their servers and storage, et cetera, and bring those technologies and that method of building out applications and infrastructure to other companies and organizations throughout the world through open source software and products.
Well, it's interesting because even at the scale of my smaller client, Insight Cruises, there's still a problem of having like a couple of web servers, a big, powerful database engine, and things like mail services and things like that. And we're actually moving towards using containers and things like that because it just does make things a whole lot simpler. It also means we can do our development locally on our laptops, and we know we have pretty much the same code going on. But my other big client, ZipRecruiter, of course, has dozens of machines, mostly in AWS. EC2, and they're looking at the kind of solutions it would take to move towards something like Docker and things like that. So this is definitely a hot topic these days, and it's come quite a ways in the last few years. Can you kind of tell us how the lay of the land has moved forward?
For sure. So when we last spoke, we were very early on in the whole ecosystem. CoreOS is a company, and the namesake of the company is the first product that we built called CoreOS Linux. And like you said, CoreOS Linux is this minimal operating system designed to run containers primarily. Now that's one piece of the puzzle. This is a piece of the puzzle that we're really passionate about, and we started at the lowest level because we felt that that was the part of the infrastructure that needed to be tackled, and that we would move up the stack over time. And so what's happened over the last 2.5 years is a lot of new open source technologies have been built, and the technologies have gotten quite robust and featureful over that time period, to the point that we're seeing a lot of deployments of some of the core technologies that we're building through a lot of companies all over the world. So what's changed is essentially the technologies have started to move into production, and the technologies through collaboration of a bunch of different companies have gotten to the point where they actually feel fun to use. There's always this like point in technology where early on it's kind of, you're writing the compiler, the low-level details are kind of complex, and then you get to this point where you have like the interactive prompt on a Python or Perl command line where it's actually becoming fun, and you can it's almost like you can like playing music, you can kind of play around with it and be creative. And so these technologies around containers and infrastructure are getting to that point where you can kind of be creative with them.
Okay, and so the containers then, as I said in the opening of the show, the containers sort of allow you to separate some of your concerns. In other words, you can have it so that somebody, say, if you had both a database and a web server on the same machine, there might be some attack vectors and things. So this helps with security, right?
Yeah, so to break down the sort of technology, what's going on is that up until now, before containers, what a lot of people would do is they'd use configuration management or their package management systems, and they would spend weeks on end trying to figure out how to build and deploy and then actually run their application on the servers that they purchased from Amazon or that they've racked into their own data centers. And so one of the complexities there is that you have to spend some time thinking about, well, what happens if that version of Python that I'm running my application on today, I actually need to update it. Well, now I have to, say, double my compute resources because the application today is using Python 2.6. I want to update to Python 2.7 or Python 3. And now I have these two sort of different environments, and this causes complexity for the operations team, and it causes complexity for the engineers not knowing what environment that code's going to land in. So the interesting thing about containers is that you can put them onto a machine and remove them. You can run multiple containers side by side that are in completely isolated environments. And so it allows you to push consistency from, like you said, your developer's laptop and have that same environment that was on the developer's laptop actually appear on the server. And it's not just sort of how we've been thinking about VMs, where like I spin up the same VM that's on my laptop in production. I'm actually running the process on my laptop, say this Python process, and that Python process is fully isolated on my laptop. And then when I push it into production, it's isolated in that same way on the VM. But it's not using not using the heavyweight technologies of virtual machines. They're actually just regular Linux processes on the servers.